All right, hey folks, we are in the final video for this unit packet, and we recently covered how to find the area of these shaded regions. That was what you guys covered in the last class. So what we're going to go back to is composite figures. And again, the composite figures are when you see like a trapezoid and a rectangle, or for example, here we have a semicircle and a rectangle. So composite just means like a bunch of stuff kind of put together. And in this video, instead of finding the area like we already did, we're actually going to be finding the distance around. So these shapes should look familiar because we already covered these shapes and how to find area of these shapes. And so now on this page of the packet, I'm using just the same shapes, and instead of finding the area, we're going to find the distance around them, okay? Now the distance around is generally called the perimeter, but perimeter is when you're talking about a polygon. We have circumference when you're talking about the distance around a circle. And since these are composite figures, instead of calling it circumference or perimeter, I'm just going to say the distance around it, okay? So let's get started here with this first shape. And with this first shape, we're just trying to find the distance all the way around, okay? Now the good news is I have a 24 that I can add up. I have a 13 here. I know if this is a 13 that this must also be a 13. So I've got these three sides accounted for. I've got the top side accounted for, that's a 13. The only thing I don't know are these sides here in red. Now we also see that if this top part's a 13 and the bottom part's a 24 all the way across, if this is 13, that must mean this much is 13 right here. So let me get my calculator out, and we're just going to do the 24 all the way across minus this 13. That's going to be this part and this part, the 11. So I'm just going to divide it by 2. So that this part is a 5.5 and this is a 5.5. So I've got the entire thing figured out. It's 5.5, 13, and 5.5. Now the reason I care about this, y'all, is because I need the right triangle to find that missing kind of hypotenuse right here in red. We know that the height of the triangle is this 13, and we just found the base to be the 5.5. So we can use the Pythagorean theorem to find the hypotenuse here, which means we will have found this side. All right? So the Pythagorean theorem says that I'm going to do 5.5 squared, and that's a 30.25. And I'm going to add that to 13 squared, and I know 13 squared is 169, so I'm just going to add that to 169. So now I've got a squared plus b squared in my calculator, and I'm going to take the square root of this number, and I'm going to round that to a 14.1. This is going to be a 14.1. So we know this is a 14.1. Therefore, this is a 14.1, and we now have all of our sides to simply add up the distance around. I'm going to use my calculator here. I'm going to start with the top part, and I'm just going to go clockwise. So I'm going to start with the 13. I'm going to add a 14.1. I've got another 13. Now I'm at the bottom with the 24. Coming up the other side, I've got a 13 and a 14.1. So when we add up all these sides, I've added up 1, 2, 3, 4, 5, 6 sides. So that's going to be 91.2. And we have it labeled as inches, so 91.2 inches. Okay? So distance around the shape, we just add up all of our sides. So for this one, we have a 7. We need to find the distance around this curvy part. We have a 3. And we need to find this slanted part, okay? I'm actually going to start this time over here with the circle. We're going to try to find this red part right here. Now I'm given the diameter of the circle is a 4. So I'm going to use this formula right here. Circumference, the distance around a circle, is pi times the diameter. Now the only catch I can see here is that I'm not going all the way around a circle. So I'm just going to cut this answer in half, and I will have the distance around just this semicircle, okay? So pi is 3.14. The diameter in the picture is a 2. All the way across is a 2. And then we're going to multiply that and just cut the answer in half. Oh, whoops, sorry. I put a 2. I should have put a 4. Ha! I was getting ahead of myself. The diameter all the way across is a 4. There we go. And then that's what's going to get cut in half. Okay? So I can do 3.14 times the diameter. Now that would be the distance around the full circle, but since it's only a semicircle, I'm just going to cut this answer in half. So the distance around my red part right here, this is a 6.28. So I'm going to put this right here. I've got a 6.28, and we can round that to a 6.3. We'll round that to a 6.3. Okay, we got a 6.3. Cool, so we found the red part. Now let's focus over here on this. Now I'm going to just extend here. Let me just extend a dotted line and show you guys if I extend this dotted line, I've made a right triangle. And that right triangle, if this is a 3 right here, this much of it is 3. So I know from here on this has to be a 4. Okay. So I have a 4 here and a 4 here. So it looks like we have a 4 by 4 right triangle. So we're about to do just 4 squared plus 4 squared. So just a 16 plus a 16. And when we take the square root of the 32, that'll be this hypotenuse. So we know that 4 squared is 16. I'm going to add them up. 16 plus 16. Cool. Now when I take the square root of that, I'm going to round it here. This will be a 5.7. A 5.7. So we just found this side to be a 5.7. Cool. So now we're ready to add up all of our sides. We've got a 7 plus a 6.3 plus a 3 plus a 5.7, and we've gone all the way around this shape. All right, so the numbers I just said, we had the bottom 7. We had the 6.3 around that semicircle. We had the 3 up top, and then we found the hypotenuse to be a 5.7. So that adds up to a straight up 22. So the distance all the way around this one is going to be 22 meters. Okay. All right, let's take a look at what we're seeing here. So area, we'd see the rectangle and then a semicircle on top, which is great. I still see that, and I still care about that for the distance around. So for the distance around, so far I have a 2.5, and I have a 1.5, and I have the 9.2. I also know this part right here, if this is 1.5, so this has to be a 1.5 right there. The only thing I don't know is the distance around my semicircle. And we just talked about that. We can use the circumference formula, and we'll just cut it in half since it's only half of a circle. Okay. Now I do need the diameter of my circle. So let's find the diameter real quick. Well, if this much of the rectangle is 2.5 and the entire thing is a 9.2, I'm just going to do 9.2 minus that 2.5. So the 9.2 minus the 2.5 tells me that this whole diameter across is a 6.7. So I have my diameter across is a 6.7. And I'm going to use that now. Let me get my circumference formula down here. So basically we're just going to do pi times 6.7, and then I'm going to cut that in half since it's a semicircle. Okay, so I'm just going to show that work here. The diameter is the 6.7. Then I'm going to cut that in half because it's a semicircle, and that's going to get me this red distance around. So 6.7 times 3.14, and then divided by 2. So this is going to just be a 10.5, 10.5. All right, cool. So now we're ready to add up the 1, 2, 3, 4, 5 sides that we have. Let's start with that red side that we have in there, the 10.5. I've got that added up. All right, now I've got this 1.5. Now I'm at the bottom, the 9.2. I got another 1.5 over here. And last but not least, I got the 2.5. So total, this is going to be a 25.2 centimeters, 25.2 centimeters for the distance around. Area would have been square centimeters. Distance around is just centimeters. Okay, so make sure you've got that, again, inches. It's not square inches. Area would have been square inches, but distance around is just a length, so inches. All right, and now we're on the last one here. So for the distance around it, again, I've got a 10, a 12, a 4, an 8, and then we don't know this side. Now this side is the hypotenuse of this right triangle. So I need the dimensions, the legs, so that I can find the hypotenuse. If this rectangle part is a 4, we know this is a 4, So that means this height has to be a 6. Okay. And then down here, if this is 8 and the whole bottom is 12, then 8 plus 4 would make the whole thing a 12. So now we know what the right triangle dimensions are, and we can do 6 squared plus 4 squared. And then when we take the square root, we'll have our red side. So I know 6 squared is 36. I know 4 squared is 16, so I'm going to add that up. And now I'm going to take the square root, and that's a 7.2. So the Pythagorean theorem is wildly helpful here. And now we are ready to say, okay, I've got the 10. This is the whole 10. So 10 plus 12, I'm at 22. Okay. 22 plus 8 is 30. Now I'm at 34. And last but not least, when I add 34 plus my red side, 7.2. So 34 was the last thing I said, and then I've got my 7.2. So when I add those up, it's going to be a 41.2. 41.2 feet. So a couple things from this video. Perimeter, distance around circumference, very easy concept. You just go around the shape. You might need your circumference formula to be cut in half because it might only be a semicircle. You also might need to bust out the Pythagorean theorem to find the missing kind of slanted side. And it's good that you have the skills from earlier in the unit to kind of see here that if I break it up like this, then I have a base and a height. I have 2 legs, and I can use that to find the missing hypotenuse. So we've finished the 4 shapes on this page, and what you guys are going to do now is turn over and try these for practice. Friendly reminder that anytime you see those little lines, it's meant to show that sides are the same. So for example, if this side in this shape is labeled with a 3, anything else that has that little tick mark on it is a 3. So like that's a 3, this is a 3, a 3, a 3, and so on. Right here, if you see the little lines, this is a 9, so you can assume that this is also a 9. Now I don't have the lines here, but you can assume this 26 and this 26, that's an isosceles triangle. And then we have them here and here to show that that's a 6 by 6 square. So for these shapes, you're getting ready to try to find the distance all the way around them now, and there will be a Google form for this. And that concludes this video. Thank you for watching.